Okay, let's send everybody a link that we are going live. Boom. And boom. And boom. Okay, I think that's all of them. Okay, let's get ready for Advent of Code Day 19. Let me see. Okay. Might as well open up the webcam, right? Not just have a big black square on screen. Let me move. I got my headphone tangled. This is a great start. Okay, let's do this. Let me just okay, let's start reading day 19. Beacon scanner. As your probe drifted down through this area, it released an assortment of beacons and scanners into the water. It's difficult to navigate in the pitch black open waters of the ocean trench, but if you can build a map of the trench using data from the scanners, you should be able to safely reach the bottom. Let's see. The beacons and scanners float motionless in the water. They're designed to maintain the same position for long periods of time. Each scanner is capable of detecting all beacons in a large cube centered on the scanner. Beacons that are at most 1000 units away from the scanner in each of the 3 axes. Okay, so it's 3-dimensional. Okay, let's see. Have their precise position determined. Hey, Luke. Relative to the scanner. However, scanners cannot detect other scanners. The submarine has automatically summarized a relative position of beacons detected by each scanner. Your puzzle input. Thanks. Yeah, I'm gonna need it, I think, as we move on to the end of the series of challenges. They get harder and harder and harder. So at least that's what it's supposed to. So I have not read it yet. I just read a tiny part. Okay, there's lots of stuff here to read. Okay, so probably today will be another long one. But yeah, we'll see. I'll app you if I need help. You can come over here and help me. Let's see. So I was reading about the unit positions. Let's see. Each scanner is capable of detecting all beacons in a large cube centered on the scanner. Yeah. Okay. I read that. However, scanner cannot detect other scanners. Yes. The submarine has automatically summarized the relative positions of beacons detected by each scanner. For example, if a scanner is at XYZ 500 -500, there are beacons at those places. The scanners could report that the first beacon is at okay, relative to the scanner, would not be able to detect the second beacon at all because it's just out of range, right? It's 1 over. Unfortunately, sure, I'll be the helpline, okay. Unfortunately, while each scanner can report the position of all detected beacons relative to itself, the scanners do not know their own positions. You need to determine the positions of the beacons and scanners yourself. Oh my god, this is gonna be tense. I already know. But probably you'll get readings and then you have to map out like the blind spots and do triangulation of everything. Man, that's this is gonna be intense, I think. Let's see. Unfortunately, what you can yeah. The scanner and beacons map a single contiguous 3D region. This region can be constructed by finding pairs of scanners that have overlapping detecting regions, such that there are at least 12 beacons that both scanners detect within the overlap. Okay. By establishing 12 common beacons, You can precisely determine where the scanners are relative to each other, allowing you to construct the beacon map one scanner at a time. Okay. So what you probably have to do is just get the relative offsets between these and find those, right? By establishing 12 beacons. For a moment, consider only two dimensions. Suppose you have the following scanner reports. So this is +4 -1. So +4 and -1, so yeah, that's this. Okay, because, yeah, you have to do the absolute probably. So it can go both ways. Because the difference here is 1 in absolute terms, and here as well, but it's flipped the other way. And then you go 3 and 1. So this one doesn't. Okay, let me see. I'm probably jumping to conclusions here. Let me see. Drawing an X, increasing rightwards. Y increasing upwards. Scanners as S and beacons as B. Scanner 0 detects this, right? So this is the same shape but offset by 1. Is that true? So that would mean just below this one, scanner 2 would be. Yeah, okay, so I got that right. Because you can look at the relative positions between those, between all the beacons. Still have to figure out how we can know that the scanner is here though, but let's see. For this example, assume scanners only need 3 overlapping beacons, then the beacon visible to both scanners overlap to produce a complete map. Unfortunately, there's a second problem. A scanner also don't know their rotation or facing direction. Okay, I was afraid of that. Damn. Due to magnetic alignment. So this is basically like the jigsaw puzzle thing from last year, where you also had to do all the rotations and flipping, and man. Okay. Let's see. Due to magnetic alignment, each scanner is rotated some integer number of 90-degree turns around of all the axes. Okay. Oh yeah, and there are 3 axes now. Jesus. Positive X. That could be negative 1. Okay. So one scanner might be upside down for the perspective of the other scanner. In total, each scanner could be in any of 24 different orientations. Yeah, because it's 8, but in 3 dimensions, right? So you have 3 rotations, 4 rotations, 2 flips. That's 8 times 3 axes. Okay. Okay, let's see. For example, here's an arrangement of beacons as seen from a scanner in the same position but at different orientations. Yeah. By finding pairs of scanners that both see at least 12 of the same beacons, you can assemble the entire map. For example, consider the following report. Because all coordinates are relative, in this example, all absolute positions will be expressed relative to the scanner 0, 0, using the orientation of scanner 0 and as if scanner 0 is at coordinate 0, 0, 0. Okay, scanners 0 and 1 have overlapping detection cubes. The 12 beacons they both detect relative to the scanner are the following coordinates. Let's see, these same beacons in the same order but from the perspective of scanner 1 are blah. Because of this, scanner 1 must be at... Okay, I still don't know how we do this. That is probably just building min-maxes of this to see where it can still detect all of them and then take the ones that don't match and use them to... So let's say you have you have one of them. Let's see, these are the 12 common ones, right? So what you could have is that one of the scanners is here and the other is here, and you just take like the min max and if it detects some more here, the gray one detects these two but it doesn't, and then you can shield off like, okay, that means that you can't visit here, something like that. So I have to get bounding boxes for everything and then cut down the radius of the shapes that you can see. Okay. Full list of beacons relative to scanner 0 is blah. Okay. In total there are 79 beacons. Assemble the full map of beacons. How many beacons are there? Jesus. So we have 38 scanners in this case. I wonder if I'm even able to do this. This is really complicated, because what you need to do is because you don't know which ones of these will match yet. So that means you have to cross match all of those readings and do all of the projections as well. So yeah. That is really tough. I'm still thinking about how I'm going to approach this. Let's see, here's an arrangement of beacons as seen from the scanner but in different orientations. And these are just 2, 4, 5. These are just 5 ways of the 24 that you can represent this. So probably what I first need to do is build out like a way to transpose all those positions in 3 dimensions for all rotations. Man, something just tells me like the way to do it would be to calculate like the offsets between all of them and then find matching offsets, but I'm not sure if that works. Let's see, because everything reported is relative to the baseline, to the scanner, right? So everything here is relative to the scanner. So these are also positions relative to each other in respect to the scanner, but yeah. I'm just thinking, is there a way to normalize these offsets between each other? Because I actually don't really care about the offset from the scanner, because that's pointless. What's interesting is the relative offsets towards each other. The only issue is that they can all be, like, you don't know from which side it's scanned. So I was just wondering if there's a way to map those, right? Because, like, if you paint. If you have that cube, my amazing drawing skills, and let's say just the scanner is here, and you have something to measure here, and something to measure here, and something to measure here. If it's measured from here, like, these offsets will still be the same. It's just that the how do you call it? The absolute values will, like, the exact positions will change. So what I'm thinking is, if I could calculate the distance between the 2 points for everything that is scanned, and then see if you can map that. So, like, you take the absolute position in 3D between this one and this one, but also between this one and this one. So let me just... So you calculate the distance between these two, but also between these, and between this, and between this. And you do that for all of them. Then you have a set of numbers you can sort. And then you can compare against the other groups to see how many of those numbers match. And a match doesn't have to mean anything, but then you can combine actually more numbers that match, and then you can see maybe how you can rotate all the things to see if they will line up. Another thing you could do, another thing you could do is just map all of them in, you'll never know the actual numbers, so that sorry, so that will be an issue. I think that's the easiest thing to do, to find, like, the offsets between the measured things, because those are always the same no matter which way you look at it, right? Then find how many matches you can get. I think that's an idea, because then you could see how many overlapping numbers you have as a candidate to spot them, and then you can look at how the numbers relate to each other to find out the position and rotation, and then you can do more validation to see if it all pans out. Because then you can take, like, both offsets and translate them to line up on each other, and then the other numbers should also match. I'm just wondering if that's the way to go. And I'm wondering if I can be naive about the way it works. I think I should actually take, like, the test inputs. Do they have a good test input? These are 4 scanners. And here they have all the beacons. Okay. The full list of all beacons relative to scanner 0. Okay, so this is the answer list, right? The mapping. So basically, if I take this as the test input, I can test my hypothesis to see if that will work. Not gonna lie, this is gonna be a very tough one, and I'm not sure if I can even pull it off. So yeah, let's see how far we get. It's a very cool challenge though. So I'm gonna have fun either way, I think, but I'm trying to manage expectations already. But yeah, this is a fun one. This is the biggest challenge I think so far this year. Let's see how far we get. Const string test input is at boom. Right, okay. So we split by double new line in this case. So let's see, for scanners, right. Test input, split by. So that's a double new line here. Now we do select. Okay, so this will be a list of string. Dun, dun. Okay, now we do x dot 2 lines. And then we skip one and we take that. So now we have a list of string, right? Okay. Oh. Okay. So these are the scanners. Boom, 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 boom. And then every line. Okay. So these are the scanners. We do 2 lines, we skip the first one, and then we can actually do select y dot split, comma, as the 32s actually. Is this an IEnumerable or a list? No, it's a list. Okay, so now we have a list of lists. Okay, yeah. Basically it's XYZ, so yeah, that's correct. Boom, 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 boom. We probably need to have helper classes here to help with all the transposition and stuff like that. So let's just see public class probe. Public int x set x, a y, and a z. But I prefer reading that in lowercase, but yeah. Public int x, y, z. And we will need to implement ways to rotate, and probably we need to rotate all the stuff in the grid, because they will be all relative to their values. Actually, if they rotate, you can change the origin, so you can also, let's just do we can do public int x, int y, int z, position, and we can have the same for origin. So that origin in our case will always be 0, 0, 0. But once we get to rotate stuff, the origin moves as well, so we need to keep track of that later. So we do public probe must be compile time constant, right? Yeah. It's too bad that it can't detect that as such. But that is fine. We can just do an overload like this and then do something like that. I just need to close this, right? We also need to have the position here, so we can do the same. Position. I could probably have one from that parses it from the string, but I think this is actually fine. But in this case, I should probably just make sure that I have a constructor that just accepts this and then builds it. So let's also do public probe string raw, and then we do raw like this. Like that, and then we can do would be nice if you can call the constructor from there, but yeah, it doesn't matter, I think. Actually, I can do it as let me just do position is XY. Did I call it XYX? Something like this. Okay, we have all the variants here, and I could probably just do new probe. So now we have scanners as a. This is a list of probes. Is that correct? Yeah, because the outer one are the scanners, and each scanner has a list of probes. Okay. Can we get an absolute distance between 2 points here? So public int distance from, and then we get this one, other position. Then we could do map.absolute position position.x other position.x minus this. So this should give us the the absolute distance between those two. Like if you go step by step, how many steps are between them. So let's see, for each scanner and scanners. Okay, now we have the scanner has probes. Let's do dictionary int list int probe distances is new bloom. Do list int distances is new blah, and this will be scanner dot count. And here we do probe distances dot add probe distance dot count comma distances. So here we build up a list of all those mappings, and after those are done, we should probably try to see which ones can have the most matches. Let's see. So we do for each. I have kept it on for each probe in scanner distances add probe dot. Oh yeah, then we need to have yeah, we just need to go from one to all the others. So we do, we call this other probe. Then we do if probe, if other probe is probe, continue. And else we do distances dot add probe the distance from other probe. Other probe dot position. Okay, so now we have that built up. And now we go. We do the same for each var scan distances. Actually, in probe distances. I could do actually a for I for int outer is 0 outer. I could call this 0 a smaller than probe distances that count. Increment a. Do the same for b. If a equals b, continue. And here we try to do a matching count. So let's see, we do probe distances a dot intersects. Let's see, using the default. Yeah, the set intersection, right? Intersects probe distances b. Var match count is this. So let's just write it out for now. So the console that right line. So we have A to B match count. Okay, so let's just see what this does, because this was just a shot in the dark for me and I have no clue what I'm doing. So let's see if this works. Okay, so there are some with a high number of matches and there are some with very low numbers of matches. So 0 and 3. Yeah, I don't need to do it like that. I just need to be smart about it. So B is starts with A plus 1. So this gives all the unique combos, right? So I have one that match 83. How can they match 83? How, there are not even that many probes in there. The same issue I had here. I should probably do this. For int a is 0, r smaller. No, wait. Let me think. Yeah, these distances, I did it wrong here. So we need to do the same AB thing. For int a is 0, a smaller than scanner.count, increment a, same for b, but it starts at a plus 1. Okay. So this never happens. So this becomes scanner A. Scanner B. Let's run it again. What am I doing wrong here? Let's see. Fruit scanner and scanners. How can there be 300? Okay. Are there that many readings in those lists? Yeah, apparently. Okay. Okay, so this isn't getting us as far as I would have hoped. Let me think. Let's go back to the drawing board. Because my initial idea was that, like, that you can find how they relate to each other. The danger here is that this is a really tough one. Um, because the thing is, you have to compare yourself to all these others and create like a representation that can be viewed in many ways. So let me just go back right here. Maybe the trick is to actually create like a smaller detection part that has to be seen for because like if I build up the boundaries for the scanner, so let's say int x, int y, int z, int x. I can do like this, min, max, get cube, and this will be a list of this points. Okay, so we do int min x. I can do this min max. This actually needs to be like well, first is points dot first. So this becomes first dot x, first dot y, first dot z. And then we do for each var pos in points dot skip one. If pos dot x smaller than min dot x is pos dot x max. Goes the other way around, max y max y z. Okay. Bum, 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 bum. I'm curious to see what this yields if I do this for each scanner. So we do for each bar scanner in scanners. Cube scanner. Fine. Okay. So we do console.writeLine. This So we do cube dot min dot x cube dot min y cube min dot z cube dot max dot x cube dot max dot y cube dot max dot z, and then we do cube dot max dot x minus cube dot min dot x plus 1. So this should give us the dimension of the these last ones need to be y. Let's change that. I'm sure we'll need this down the line, but so far I still don't know how to solve this issue even, so that will be entertaining. Okay, that's weird. So these measuring cubes, oh yeah, because it can go 1000 each way. Okay. So I can actually visualize the cube of the scanners now. And if I can figure out which of those which of the ones over are the same, then I could also map it all out. I need to stare at the numbers some more. Let's see if I manage 12 the same beacons can assemble the entire map. I wonder if what I could do is get like the relative distance between 2 points. So we have this one is different from. So what I could do is get relative distance. Relative distance from other position, and here I can just actually return this. Right, and then we need to find a way to transpose the position, and if we test all 24 rotations and then all the relative distances between them, there should be able to we should be able to find better matches because it's more exact. But now that means that we have to rotate and flip all of this. So there would be a public void, let's see, and it's all based around origin, right? So we mean let's do rotate public enum axis x, y, z. I need to shrink my screen because I took that off screen, I think. Let's see. So we have an enum here and a rotate axis. Okay. Cool. I'm just thinking about how to even do this. Let me see. Man, this is tough. I'm just trying to wrap my head around it, and what it actually means to flip all of this relative to your origin when you don't know much about the rest. Okay. That is interesting. Not sure if it's interesting enough, but like all these numbers, only their order and positive and negative change. Because I was just thinking if I like just make them all absolute and sort by number, then I'll have man. But still, like if you change the rotation, I keep coming back, like when I visualize it in my head, I keep coming back to when you have these points in 3D space, the relative positions towards each other, that's the stuff that that's the stuff that doesn't change. That's always the same. So I wonder if I do this, then I'm not sure how how well I'll do this thing. Let's just delete it for now. And let's make an extension method. Let me just make this here. This apps val. That doesn't account for the ordering still. Because I kept thinking, like, if I have a way to express all the relative distances, but I think you actually have to no. I think this one will be the key, but you just need to compare all of them, and then so we don't need to actually compare the scanner, but just from considering like each probe and all the other distances, right? So I can do actually public list int other probe distances. Dun, 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 dun. So if I do public void update distances IEnumerable probe other probes, and I can do for each var probe in other probes if probe is this continue. We don't want that. And else let's do how did I call it? Other probe distances. Clear. Other probe distances dot add relative distance from probe. Okay, let's see. False. Like that. Oh, no, I need to do distance from. Sorry. Yeah. And then I will have to do all the rotational stuff at some point. But let's just see if this can give me a better feeling about it first, because if this doesn't work, then I think I just need to cut my losses and not do this one now, because I won't have time to figure it all out. I really like the challenge, but I don't have enough ideas on how I can actually do this, so that'll be a tough one. I might try to implement the rotational stuff just for fun, but yeah, let's see. Probe distance count here. So what I can do here is just probe, not probe distances. So this was scanner, yep. And I can do scanner a dot update distance scanner. Actually, this should work. It will filter itself out anyway, so that is good. So this wasn't that great, so now we do for each var scanner scanners. For each var probe in scanners, a scanner. Now we do the same. Other scanner. If other scanner equals scanner, continue. Okay. Do it for each var other probe in. Let's see. Other scanner. And now we want to do this. And this will be a scanner dot no, actually probe distance, other probe distances intersect with other probe, other probe distances. Did I write that differently? Other probe, no, probe. So anybody in chat who has done this problem today? I'm really curious to hear how it went for you. So we can do probe dot position other probe dot position. It actually doesn't matter that much. I probably need to have the indexes here. So let's do int scanner index is 0. Let's see, scanner var. I should actually just write this one out here. Console.writeLine. Let's just increment it here and have one based displays here. No, that's not. Let's just do it like this. And we do scanner index with probe index. Should reset it here, and then we do this probe index. So much debugging before even writing stuff, but hey. We do this, this is 0. And this will dump out so much info, but yeah. It's, I think it's the only way to get this the way we want it. Okay, probe index, we do other probe. We can do that in this report line actually. Okay, let's see what this dumps out. It will be a lot of info, but at least I should be able to see if my idea is going somewhere. Okay. Let's make sure it's initialized. Boom, okay. So this is interesting. $11 matches, wow. So that is cool. Should probably go back and only write this out if there is more than. Still a lot of info, but let me see. So scanner 0 versus scanner 1. Probe 0 matches 10 distances with probe 3 and just 1 with all the others. Wow, that is weird. Wait. Could that, wait, something's clicking here. Could that be that probe 0 for scanner 0 is actually the same as probe 3 here? Okay, this is cool. Let me see. So, is that written somewhere? So this one would be the same as this one. How can I even test that? Relative to scanner 0. Okay, wait. Let me get this one. Okay, so that's in there. The same 12 beacons in the same order, so that would be number 4. Yes! Okay, so this is progress. Cool. So my half-baked idea actually yielded something. Okay, so by doing my crappy code, I was able to determine that scanner 0, probe 0 with high likeliness is probe 3 from scanner 1. Okay. Okay. That makes me feel good. So for scanner 2 I have no such thing. And here, let's see, probe 8. Probe 8 also has one. Probe 8 matches other probe 8. Probe 7 and don't even know which scanner this is. Let's see, probe 16. So this is all still for the 0 one, right? They all have 10 matches. That's interesting, and 11 matches. Okay, let me do this differently. Let's just write out with the confidence of 6, and I should probably so let's do probe dot position, and here we do other probe dot position. Let's see if this if I can get this to write out better. Okay, let's see. So we have the 404 one, that's that one, matches that one. Okay. Then we have 528, that's that one. So there's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It's minus. Okay, so that one is also a match. Okay. Then we have probe 0 with other probe 0. 390. This one matches 3, 2. Okay, so that's that one. I think that's also correct. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. I'm actually surprised that this works. 537. 28. Matches with 605. Okay. So minus this is the last one. It should match this last one, which it also does. 3, 4, 5. This one. It also matches. Let's see. That one in the middle. 729. 618. Yeah, I think we get the picture. So when it matches with a lot of confidence, like 10 or 11 here, and the weird thing is there should be 12. So I'm really wondering which one it didn't match here. Well, to be true, not every beacon has to be able to see all the other beacons. So that's something to consider. So the question is, how confident do we need to be in our matches there? Because the overlap can be quite because I'm trying to figure out, right? It's up to 12. It's probably a lot of them that match. So I wonder what my threshold should be. I wonder how many we need, but yeah, we can figure that out. Okay, so that's actually pretty cool. And now the cool thing is that we can use this to figure out the XYZ difference, right? Not that I'll be able to really solve that probably, but man, this is such a tough problem. But okay, let's first do a mapping. How do I write this even? Because I can use the positions of those nodes to figure out where the other Yeah, because you need to use those nodes that match and their reported values to figure out which way the origin for the scanner is. That means that I have to find out how they relate to each other. But once I can map them, I can like see how they differ in their reporting values and use that to determine the rotation in X, Y, and Z. But it's all like, this is not something I'm very comfortable with doing. So yeah, so let's see. Let's do dictionary. Int scanner A, int scanner B. List int probe A, int probe B. Scanner probe mapping. Right. Okay. So let's see. Var mapping is new block. And here we can do scanner probe mapping add. Then we do probe index. No, scanner index, but we've already increased those, so that is great. Scanner index -1. Other scanner index -1, comma mapping. And here we can do mapping.add, and this will be probe index -1, other probe index -1. Actually, I can do it above here before the reporting. So that saves one minus step there. I made a boo there, I think. This will be other probe index. I didn't even notice that I messed that up there. So now I can do console.writeLine for each var m in scanner probe mapping. An item with the same key has already been added. How so? Ah, right. I need to change this order. So this one needs to go in here. What did it do here? this one needs to go here. Okay. Nearly there. Okay. Let's see, 0, 24, there are no... Okay, my bad, this one needs to go here. That's when you change the order of these things, it can get a bit messy. Okay, so between node 1, oh, this should actually never been inserted. We're getting there. Okay, so between and okay. So between 0 and 1 there are 12. Between 1 and 0 there are 12. Okay, this is also not needed to do this. So I should make it the same loop type as this. Otherwise you do too much unneeded stuff. What is it complaining about now? This is weird. Let's see, I wanted to copy this part. Oh, I can just, man, it doesn't even matter. Okay, so let's just do for int I. Do I use I somewhere here? Probably not. I is, I'll just the AP is scanners.count. No, is 0. A smaller than scanners.count increment A. And then we do the same for B. But we start at A plus 1. That gives us the unique combination, of scanners. So those are all the permutations. So I don't need to do that actually. Maybe. So I can just do this. Also, I can also do the same for the scanning thing. So console, right line, scanner. Okay. This never happens. Oh, we should probably do the same thing here. No, we actually need to cross match all of them because we don't know. Yes, okay. And, so I can reset probe index here. Like this, okay. And this will be scanners B. This will just be B. This will be A. Okay. Let's run this again. Okay. So that's pretty cool. So between 0 and 1 we have 12, between 1 and 3 we have 12, between 1 and 4 we have 12, and between 2 and 4 we have 12. So is that the same that they said here? Let's see. What did my code say? We have like a list between 0 and 1. So like the first scanner 1 and scanner 2. Scanner 4 overlaps with scanner 1. So that would be 0. Okay, we don't have that. I have 0, 1, 1, 3, and 1, 4. Let's see. Ah, okay, there are, yeah. They also 0 based here, so that is fine. So they say, okay, let's see. 0 and 1 have overlapping cubes. That is correct. Because of this, scanner 1 is, okay. Scanner 4 overlaps with 1, so we have that, 1 and 4. Scanner for in process, scanner 2 must be at that. We have a mapping with 2 and 4. Okay. So I think we can. This part works-ish. Not sure how it will fare for the ultimate part, but we need to find the ones that share 12. So now the tough part of actually making sure that they become in the same in the same perspective, right? Let's see. And I really wonder, did I write out scanner 1 must be at 68, blah blah blah. So I have those things here, and I wonder why it said that, right? 68 minus 12, etc. Because this probably needs to look at the cube from the matching ones. Is get cube. Do we have scanner? Let's see, m dot value. Okay. So let's do m dot value dot select, and then we need to have scanners. M dot. No, I need m dot select x scanners x dot. No, select. Actually, I have m dot key there up above, so that's not bad. I can do m dot value dot select x scanners will be m dot key dot scanner a, and then we'll take actually we will take the probe there, which will be x dot probe A. Position. Jesus. Var cube A is get cube. This. Come on. So, scanner B, probe B. Do-do-do-do. String format q string. Okay. What's the shape of the cube? That will be this cube. Okay. That should help a bit with the printing. It's crazy because let's see, we've been going 90 minutes and I'm not even close to solving part 1 yet. Whew. So I'm just trying to figure out how they, based on these, they say scanner 1 must be at this position relative to scanner 0. Oh man, I don't even have something to calculate the relative position yet. So this says nothing. Oh wait, that's strange. The B cubes are wrong because it seems to only get one value or something. That's weird. Just curious. Let's see, m dot value. Ah, it never, okay, so that part doesn't work. Other probe. This is strange. I mean, it should always increase here. So that makes sense. Let's see. Okay, so at least now the sizes show up. But yeah, all the stuff that still needs to be done is, now that I've figured out which of the points actually match, I still need to figure out how they are rotated, because I can now say, so let me just write that out here. I. Because I think actually we could do for each var la in m.value. So this is the mapping, right? Let's say var scanner A is scanners m.key.scanner A. Come on. B. Right, and now we can do var probe A is scanner A blah probe A. Var probe B is scanner B blah probe B. So now we can do console.writeline. Okay, so this will once again dump out a lot of stuff to screen, but this should tell us nothing. No. Because these are the probe points relative to their base station. And we know each one of them and how they relate to each other. So let me see. Because now I think you need to compare two known probes within each other to know the relative position. So let me just do this. For int I is 0, I smaller than m.value length count plus I. And let's start at 1 actually and compare back. Right. So we have probe A, and this means that we do m.value I probe A2. What's the problem here? Probe A, sorry. I minus 1. So we have probe A1 and probe A2. So var relative is probe A1 relative distance from probe A2. Okay. And then we get this one, probe B1. And probe, I can just copy all of this position. See, scanner B, B. So scanner B here. Okay. So now we will have the the way they relate between each other, and that should be able to tell us how we can transpose, I think, or how they are rotated. So let's see, relative A versus relative B. So we can do actually I wonder if this is enough to actually get it. So let's see here. Okay, so relative, we have this one is inverted and this one is inverted compared to each other. So that stays the same for all of them, right? Yeah. So that is basically the key to figure out how to make them all in the same how to get them to line up. So actually so in this case, we need to invert the x and the z. So that means that, like, if we take these pairs, let's just do it by hand for now. Invert x, z. So that means this becomes like this and then like that. So then you get this. And if you then subtract these from each other, that should tell us where actually the other origin is, right? If I'm not mistaken. So that would be 404 minus 336, which should be the same as 258 minus 460. That's 258 minus 460 is 68, 404 minus 326, 68, right? So this should give us so other one is x node 2, scanner 2 actually, scanner 2 will be 68. Let's do the same for minus 558, no, come on, minus, can we just reset? Boom. Minus 558, minus 65, minus 1200, and then we have minus No. It should be minus minus, so dun, 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 dun. It's just a difference between those. Okay, this is really weird. Let me just just the difference between these two. So it would be the same as 901 minus 358 minus 43. But since that one is higher, yeah, let me just see. Oh, okay, I already had the answer highlighted here, but I'm off. What did I do wrong? Let's see, if I do 588 plus 98. Yeah, okay. Whew. So that's 146, okay. So basically this is the key to decode all of this. And actually, so once you pinpoint 2, you can already calculate the rest. But the order of values can also change, so let me see. So okay, let's do void get diff. Okay, so we need to make sure it would be really nice if all 3 values are different. It would be tricky if more than one of them are the same. So let's just try to figure out that first. Okay, let's see. If method apps, no. Ax is math.absolute a.x. I'm starting to believe that I might actually solve this. So I didn't have hope before, but I'm getting hope. I just don't know which day it will be when I finish this. Man. But this is something pretty cool to tackle. Is anybody still with me, or am I talking to space right now? It's been a tough one. Let's see. Absolute. So let's see first. If abs ax is abs bx and abs ay equals abs by and abs az equals abs what bz. So x is x, y is y, z is z. So that's the first. Else figure out mapping. I can actually write this as like a func. Int map A, map B, map X, map Y, map Z. Right? I can just make this functions depending on this. If abs AX is BY and this only works if they are all three of them are different. So let me just figure that out first. If abs X AX not equals abs AY not equals abs AZ. Don't think I can write it like this, right? Yay, 3 need values. I'm not sure if I can even, I need to make sure that these, yeah, that this is the case before I even try testing. Otherwise I can't do the mapping for sure. But maybe there is a way, but I'm not gonna risk it. Throw new argument exception. Name of A. Not all absolute. So I will probably need to test that before to not throw exceptions here, but I just want to make sure that I don't forget. Okay. Okay. Let's see, B, Y is X, Y is Z, should not happen. Let's see, so if Y is X, fine, otherwise is Y is A, X, no, wait, we have, it could actually just match Y, right? Else it should not happen, okay. And from this we know all the other mappings, and then we need to still figure out the absolute ones. Okay. So let's do int null x null y null z. Okay, so first we need to make sure, let's see, if abs a no, let's see, if a.x equals b.x null x is 1. No, actually I can do map x is val, right? Yes. So that's just the projection, else map x is val and we always need to pass in the whole thing, like, okay, so we need to pass in xyz and then we get that. So we get xyz and we return xyz.x. In this case we get an xyz and we return x times minus 1. Okay, y map y. Okay, z, if it's just a straight copy we return z, and otherwise map z becomes z times minus 1. Okay, so now we have that. So in this case we have a dot y equals b dot x. Then, okay, and I need to make sure that I do the translation right. Because depending on that we need to do the inverse, but yeah. So if a maps to the b, when we want to get a we need to give b. Okay, so this will be let's see, if x and y are mapped, first need to do this here, right? If y is mapped to x, so then need to do x equals b dot y, then we return y. Otherwise map x becomes y times minus 1. Okay. In this case we have y mapped to x. That's the inverse of the above, so that is fine. If that is true we do x, and otherwise we do x minus 1. Okay, so that is also fine. In this case we have y mapped to z. This actually needs to be map y. In this case, if y equals to the z, map y becomes return z, and otherwise it's this one. Okay, and this also means we have, like in this case we have x and y mapped, so after that we do map z, then you get the same thing, z. In this case z would be, so if x is y and y is z, then z becomes z becomes x. Z is x, map z becomes x. Okay, this is stuff that will really trip you up. So throw new not supported exception, application exception actually. And the messages should not happen. Okay. Let's do the same here. Whew, okay. X to Z in this case, Z to Z. Okay. And also need to map the Z here, by the way. So map Z, so we have YX and then Z becomes just Z. So that is an option. Right? YXZ, okay. Okay. So let's see. Hey Richard, welcome. Welcome to my personal hell. Nah, it's not that bad, but boy is it a tough one today. So let's catch you up. We're doing day 19 today, and it's a doozy. So I'm not sure if you saw the question or the problem set, but it's basically you have a lot of points in 3D space, so X, Y, Z, and you have readings from all sorts of scanners, but the scanners cannot see other scanners. So you have to figure out by all the points where the other scanners are. And what I was able to do is so far is actually figure out which, yeah, I've been going 2 hours already. I'm not even close to finishing part 1. So yeah, that should give you an idea. Well, not close, it's not true, but I'm making steady progress and it's pretty cool. So basically what I figured out is a way to find out which is which. So from all the readings I can find the overlap between scanners from my hacky code, and then I can figure out, like, that's what I did here. One scanner reads this, the other scanner reads that, and I then take all of those and map it. So I can take the relative values between 2 points that are from the same scanner, see how they relate to each other, then see how the other one relate to each other, and from that create a 3D mapping. A 24-hour stream, yeah, my wife will kill me, but yeah, it won't be a short stream, that's for sure. But it's really cool, so I've been able to figure out, and this was 46 actually, but to figure out the scanner position based on that. So I'm just writing all of that, like a function to put in 2 values that should be the same, and then see how they differ from each other just by sign and position in ordering, so that you can create like a transpose method for that. So that will return 3 functions that will convert an XYZ to another XYZ. So I'm just hand coding out the mappings here. So yeah, this is stuff that you need to keep your focus on. It's really easy to mess this up. So yeah, so I basically did it by hand here to see what it would be, because I noticed that the sign was inversed for the outer values. And from that I just went on coding. This one was also flipped actually. Yeah, I missed that part. So they were all 3 inverted. Okay, so let's see. If X maps to Z, that means when I ask for X, I return Z. If they're not the same way, then boom, I need to do this. Okay, so now I do the same for this one. So if Y maps to Z, when I want to return Y, return z, x in this case, by the way. And otherwise, map y becomes x times -1. So then we do the same for map z. So we have z, so this one becomes y. So if z equals y, we return y, and otherwise we return y -1. Whew. So let's do the same here. This one is a straightforward mapping for y, and then z becomes, so we have z becomes x. So yeah. And this becomes, yeah, z becomes x. So we have x becomes z, y becomes x, and then z becomes, wait, no, y becomes x. This isn't correct. Let me see. So we have z, x, and this should be y. Okay. Y. Come on. That's what I said. It's very easy to trip up here. So we have y. If y matches y, then straight up return it. Otherwise, we need to invert it. And then it needs x. So we have z, y, and x mapped. Okay, so that is okay. So now that means that I should be able, when I do this, yes. Can I actually wait? Let me see. Let me just check with the output again, because it made sense when I saw it. Oh yeah, these two, that's it. Those are the two that I need to feed to get the mapping. Okay, let's see, that will be relative A and relative B. Okay, so I get var, and I need to return actually the mapping here. So this will be 3 functs actually. So let's see. Okay, map x, map y, map z. So did you do this one yet, Richard? This one is very cool, but it's also extremely hard in my mind. So let's see. We do var mapper is diff relative A relative B. Okay. Get mapping. Now we can do console, right line. Boom, 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 boom. So I should be able to do yes. So relative A Then we do mapper dot get map x, so that b dot x. Cool. Map y, map z, z. So theoretically, let me see. To be honest, I've given up in making a prototype for a game I may make next year. Ah, okay. Build arrows. Oh no. Okay, I think they will always be assigned, but. To be fair, this one, I thought about giving up on this one. It's so hard. Okay, what's happening here? Wait, what happened? What is happening here? Match count 82. That's really weird. Did something break? I've been coding for such a long time that it's weird because it just worked. It worked just now. So somewhere I broke something. When you finish it will be a good achievement. Yeah, this is a really cool one, but I wonder what broke because I didn't work on this, I thought. So that's always kind of frustrating. So let's just save a copy of this right now. Day 19. Okay. Day. I really wonder what messed up here, because I'm not even calling this yet, I think, right? Do we have more get mapping? No. Okay. I'm kind of gonna go Control Z here, just undo all the things that I wrote just now, because I want to see why it didn't work. Because this code was working just fine before. I want to compare. That's a thing when you code for like hours on end. Okay, so this ran before. I have the output on my screen, on my notepad here. So what has changed? It's really weird. So it's like it gets stuck on console write line for some reason. See, like I do console write line and it doesn't. Oh, okay, that's really weird. Jesus Christ. So do you know what the issue was? There was a selection in the console window for some reason that didn't allow it to continue. That is the strangest thing I've seen. Okay. So yeah, that was just me coding for an hour that you just saw. Okay, let's see what happens now. Boom. Exception. Null absolute. Okay, I can live with that. I can live with that because I don't want to. So let's see. So these are all of those. Boom, 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 boom. Okay, wait. Is this literally the first one? Then I wrote, I'm an idiot, but we already knew that. So let's go back to here, set next statement. Okay, you know what, just run again. Cool, so what you can see here is actually the translation working. So we have like 33 minus that, and we can actually translate this value to this value now, which is effing amazing. I'm flabbergasted. Oh, that's so cool. So that also means that I could yeah, because that turns them into the same space in the same rotational system. Dun, dun, dun. Let's see if they all work. I should probably just write a test. Get mapping. Var translated is okay. Let's just do it int x, int y, int z. Translated is man, this is so cool. I really didn't think I would be able to do this. I'm pretty happy with myself right now. I know I'm still not there yet, but I'm getting there. I am really getting there. Whew. So let's do if not relative a translated error translating let's see. Do we get an error translating? No, we don't get an error translating, right? No, looks clean to me. Let's set a breakpoint. Okay, cool. Whew. So now we can figure out all the points and their positions in the same coordinate system. Man, that's cool. Oh, but we're not there yet. We're not there yet. Oh. Let me think. Because as cool as this is, we're still not there. What I can do is, now that I did this, and I only need to do this once actually, I can do pom 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 pom. var scanner. Let me see. Let me think. Probe probe be translated. is and now we need to actually put in probe B1 dot pos. Okay. So that gives us the translated position for the probe. So else, boom. That means that we can now say console.writeLine, boom, and we do blah translates as blah. So now we can do probe B1 dot position to probe B translated. Come on. Probe B translated dot position. That's just that. Okay. Which also means that we can now do probe A dot get. Let's see. Is that relative distance from? No. I can just subtract those two. Actually, I can just do var scanner pos is, and then we do probe A1 dot x position dot x minus probe B. Okay, let's just also give this the same type. Dot x. Come on. So probe A1 dot position dot y minus probe B translated dot y probe A1. Okay. This means scanner should be at. Okay, and then we do scanner pos. Relative to scanner m.key.scanner a. Man, this is dope shit. I really like this. Okay. Okay, so 68 minus 12, 46 minus 43. So, if we look at this one, 68 minus 12, 46 minus 43. Boom. Gotta celebrate the small victories. That's cool. Okay, let's just break here. Break, because we don't need to. Actually, I could have done this without this if. Probably need to check it. So where are the other scanners? Do they list that out as well? Scanner 4 is at, okay, let's see. Scanner 4 relative to scanner 1, okay. But then I need to so that is basically 86 minus 88 is minus 20. Yeah, boom. Oh man, that's cool. 1, 2, 3, okay. Yeah, this is cool. So once we figure out the position of each scanner relative to the other, we can use that to build all the positions up. Man. Dun, 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 dun. So let's see, I can get scanner 4, scanner 3, scanner 1. We already know scanner 0, so that leaves scanner 2 that I don't have a reading for. Scanner 2 must be here. Okay, I really wonder how I can figure out scanner 2, because that might just be the inverse of another one. Ah, relative to scanner 2. So yeah, I have scanner 2 and 4 here. 4 and 1. Yeah, 3 and 1. So I can figure out all of them to the same position. So I need to do that now. Man. Assemble the full map of beacons. How many beacons are there? Okay. The tricky one here is... Oh yeah, and then... Okay, once you have all the scanners, then you can map all the beacons and then you can figure it out. Okay. Okay. So I think we are very close. Boom, boom. So okay. Dictionary. Int actually. I'm just thinking, like, if I have this AB offset, if I want to move the other way, I just do the inverse, right? So if it's 11 down 186 72, you do the same in reverse. Yeah, so by inverting all the signs. Okay, I probably should make this like I should probably just make a vector 3 and have all the things for it, but okay, let me just write a function here. It'll be fine. So I can do invert val, and then I can do val.x times -1, val.y times -1, val.z times -1. Okay. So this will invert, so that will be a mapping the other way around. So now I need to write like a path finding for all of those steps. So that will mean dictionary, like int scanner A, int scanner B. And this will be the whole ABC thing yet again. Scanner mapping is a new block. Okay. Okay, so here I can do scanner mapping dot add, and I do m dot key dot scanner from B to m dot key dot scanner A. So this is the key. Value will be mapper. No, actually not. No. Scanner pass. Then I do the inverse here. From A to B will be invert scanner pass. Okay. So now I need to find my way back. So that's also, now I need to figure out how many hops I can take to get back. So I just probably need to do it differently. And it doesn't matter which route. So I need to have like int, and then you have int scanner. No, let's see. I just do int scanner, comma mapping distance. Blah. And this will be a list actually, or another dictionary. There are so many challenges in this thing. It's giving me a run for my money. Okay, so let's see. If not, try get value m dot, come on, key scanner, come on. Okay, this is uppercase, scanner B, out var mappings. Mappings is new blah. Mappings, and then we do mappings.add m.key.scanner A, comma scanner pos. Okay, so that's the relative distance between those two. Okay, we need to add the key here, m.key.scanner B. And let me just do this in isolation so that I can reuse the same words. And we do the inverse here as well. So we try to find A, if not we make a new key. We have A, in this case we add B, and then we add the inverse of the scanner pass. So, this should then, man, this is such a monster. Now we need to do pathfinding. So, okay, so we do void translate to blah mapping int from int to. And then we do hash set int visited. Okay. I also need to actually have a value that we translate here. value. So now we need to get scanner mapping. If scanner mapping try get value from var options right, else throw new application, no argument exception. We have no mapping for going from blah, from name of, from. Okay. Then we do if options try get value, this will be 2 out var direct. Come on. Else try any path to see if we can get to our target. We will do return because this will be direct. Yes, okay. Bum, bum, bum. So I should probably also do subtract. Subtract. So okay, let's do avoid subtract. I actually can do AB here. A B okay. A1 position, row B translated. Okay, so that should still be the same. Okay, and in this case we can return subtract value comma direct. Else we do return translate to scanner mapping. No, we need to branch here for each option. Let's see. Bool file success result. Okay, let's do that. True, comma this. So let's see. For each var option in options. So this will be a dictionary with a key value pair, that is fine. So then we do var try test is translate to, and then we do scanner mapping. The value will actually be subtract value comma option dot value. From will be option dot key this will still be 2. And visited, clone. Okay, so now we need to do if not visited. Come on, no, I don't want to stop debugging. I should, but no. And not visited that contains option the key. Actually, I can do this. Continue. Here we do var visited clone is visited to array. We do is new hash set int. We clone this one, visited clone dot add option dot key. Come on. And this will be a recursive call. So we do if test.success return test. And so here we will do return false. No. Alright. So this should be able to translate from any point to another point. Man, it's whew. Okay. So let me see, we have the scanner mapping. So we added those. So basically what we can do now, once we've done this, we can do, okay, for each, no, let's do for int I is 1, I smaller than scanners count, increment I, okay. And now we do console.writeLine, and we do scanner I plus 1. I know, we can just keep it. And then we do translate to scanner mapping. This will actually be 0 that we want to translate from I to 0. New hash sets. And we should probably add our own index here, because that's what we start from. I'm really curious to see what this does. Boom. Will we get an error? Scanner 1. The second one is wrong, but these two are, all the versions are inverted, I think. Let me see. Probably did it the wrong way around. See, because all the signs are flipped, so I need to do the inverse there, and after that nothing makes sense. So yeah, okay, let's do that. So for the mapping, let's see. So for this case, we need to do this, and here we need to do invert. Might have applied it wrong, that's also fine, but let's see. No, I think I did something wrong there, right? So that one is correct. Scanner 4 is at -20 and that one isn't correct. I get a different reading there. This one is correct. This one is incorrect. Close, but no cigar. So let me see what's wrong. Because this relative to scanner 1 was correct. Let me see if I not do this. So let's see, int I is 1. One is 4. What is actually the error? Okay, let's just do this. Okay. So how many options do we have? We have one that goes to 1. Let me think. So the first one actually let's see. So there's a direct one here. So what is the value? So this one should have worked. Let's see. Okay, so that one needs to be inverted there as well. Let me see. The second one, like this. No. Let's see. We had this. Oh, we had this. Let me see, I need to switch back those inversion things, I think. Because this is correct, but we tried to go backwards, so now I need to do convert like this. Let me see. Let me first see what it spits out, because I think this one is what it should be. Yeah, it's actually correct now. right? Minus 20, yeah, okay. Because we had the mappings correct, but when you want to walk them back, you need to subtract them. So that is cool. Okay, so if I go back to my test code to do all of them again, does that mean that we get all of them correctly now? So let's watch the code again. 68 minus 12, 46 minus 430, okay. Scanner 2, 1105 minus, oh man, that one isn't correct. How is that possible? Okay, that sucks. 20, scanner 4 is also not correct now. Wait, what? What did I do? That is weird. I just tested it for 1 and 4 and it worked. How come? Was I crazy? Was it just a different result? Was I? I thought I had it. Oh wait, 1160. So the 1160 is correct, but the minus this one isn't correct. Oh wait, that's also the projection thing that I need to use, right? I should actually save the translation. Yeah, I need to translate the values, but I did that, right? Let's see. Scanner mapping. Because I probably need to have the translation function actually in there as well to make sure that it translates the right way. Oh man, I'm so close, but I'm also getting tired. Because a move between two of those doesn't really have to mean that you can move that in the same way. So relative to scanner 2, sorry, can't stop around, got an early start tomorrow, good luck. Yeah, thanks mate, no problem. It's always nice when people drop in and say hi. My coffee's cold. I'm gonna get a quick drink. I'll be back in a few seconds. Let me just getting drink, quick break. Okay. So let me mute and Okay, I'm back. Let's set this back to 12. Whew. Okay. So the challenge is probably that I still need to keep like the functions to translate between those. So let's see. There was this thing. So we have offset, but also mapper. Just a very, very small data type by now. Let's see. That's mapper. Okay, and now here we need to do this, but also the inverse of these two. Okay, so now that we have that, what's the error here? Okay, translate to. This type needs to be updated. It's getting a bit ridiculous like this, but yeah. So what I'm wondering is if I can do this still. Because my thinking is that you actually need to and I probably need to make a function to make this all less verbose. So let's see, because this becomes a mapper. Alright, so I should make a function called it just says map. Then we have a value and then we have the mapper. This will be val. Okay. It's becoming a real monster. Yeah, let's see if I can figure this out. So because I say invert here, but I'm not sure if I need to do invert or just map. Direct dot offset by direct dot mapper. And if that needs to be the inverse, I'm not even sure. I actually think this is only when you move between systems. I'm not really not sure. See, because here it says subtract the value. But is that correct? Because that might need to be translated still. Oh wait, yeah. Option valued of mapper. Yeah, this might actually be map. Like this, and then we remove that. Maybe this is the... I wonder what happens when we do this. Let's see. We get a build error. Okay, cool. Direct. I don't think it actually did. I don't think it did anything there except mess up this one as well. So this one is still correct, but yeah, that was because we already knew that one. And I think the others got worse even, so that's certainly not the way to handle it. So let's see here. We should be able. We should be doing the 4 to 0 1 here, but we take the 1 option here in this case. Right, and now I really wonder what happens when I do this. In this case, I just need to make sure that I, because the offset is 88. We've seen that before, right? Where's the call stack? Okay, let's see. We have this one. And the other one was scanner 4 would be this. Let's see, scanner 4 relative to scanner 1. Let's see. So we have minus 43 minus 1061. Yeah, so you just subtract those two. So let's see. What are the values that we were working with? Value is 0, 0, 0. Okay. Boom, 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 boom. Offset. This is the offset to go from 4 to 1. So if that's the offset from 4 to 1, so you add that to your position to get to the other one. You don't subtract it. Well, when you subtract the inverse, that does the same. Let me see. So you have no. I think it needs to be the other way around. Let's see, if we have that value and we remove that, we get to 4. So we need to do the inverse there. Man, this is messing with my head. So this is what we need to add to our current position to go to 1, actually. Yeah. So to go from 4 to 1 in this case, we need to add the offset that we had, not subtract it. Well, you subtract the inverse, that will do the same. Okay, let's see. So we do subtract. No. Let's say this was our value. We do subtract. Option dot value dot offset. But we need to do the inverse of that. Yeah, we need to go from there to there. So if it's this, and we do invert, then we get there, right? 68 minus, no, you don't get there. Because then it's not correct, okay. So So we don't need to invert, we just need to add the offset. Is that correct? Ah, but this one is, the middle one works in a different way, and that's probably because of the mapping, right? Let's see, map value option dot value mapper. But this probably needs to be offset. Option dot value dot offset. Oh man, that flips it around even more. Phew, this is hard. I'm so close yet so far away, you know? Let me think. Because we figured out the rotation. I'm just trying to think of just writing it out as a string, just to have some debugging here. So we can add like that. So this will at least describe the mapping for me, and that way I hopefully can make sense of the way to decode this further. Because I think I have everything I need, but I'm just not sure if there's something that's not clicking yet. So this will let me write out the mapping for each planet transition, and that maybe will help me to see if what I need to do to find my way back, right? Because I know the offsets, I feel like I'm very, very close, but not quite there yet. So this is X goes to Y. Minus Y. X goes, okay, this is Y goes to Z. Negative Z. Z goes to Z. Gypsy. We've come such a long way. It's, I just want to finish it right now. Because I can always taste it. It's so close. Because after this, the only step that's needed is to map out all the points and figure out which ones are the dupes. And I actually can already do that without resolving this, but I just want to do it the proper way, you know? But maybe I'll just code up a solution for part 1 and call it for there. Oh, damn. So much more. But yeah, this really felt like the Loch Ness puzzle from last year. Similar vibe, similar way of coolness to me, at least. It really appeals to me solving this puzzle. Oh wait, is there a bug here? Ecstasy, ecstasy. This should be Y to X. Okay, I'm just okay, my bad. So this is set to Y. Really looking forward to seeing other people's solutions for this day. So this is Y to Y. Y to negative Y. And this is Z to X. Okay. 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 Output. There must be there, right? Let's just wrap this one more time and call this the mapper. That will let me still pass that type along and not mess up too many things. So just need to do dot mapper here. Map relative B, no. Relative B. Mapper dot mapper. Yep. So that's that. Position mapper dot mapper. All right. Okay. Okay. So map like this, map info. let's run this. Okay. Okay, so that is good. I just got to remember that based on those mappings, you need to change your angles. Because while we translated 2 points to get that position, that doesn't mean that the element position is like that. Okay, let me think. This means yes. That's correct. Oh, and also I don't need to translate. Yeah, I know what I need to do probably. Because I first need to translate to the other part. I need to do the translation part differently. Let's see, 3. So let's see if I can actually figure out the probe points. I first need to do this mapping. Because I thought like we have we know which probe point is which. Well, do we? Okay, let me just see. For this part, I actually need to go from 0 to that point, because I need to translate my point to there. So I'm curious to see if that changes anything. Because I think I can just do this now again. Let me see. So if I go the other way around, the values are inverted, so I need to fix that. But it's still... this one still isn't correct. But that's also because this one isn't correct. Okay, let me see. Is this looking better now? Yeah, are not correct. So, and this is probably also because of the rotation. Huh. I think I have all the info here. I just need to figure out how to bloody fix that. Let me see. So we have those relative distances here, and from that we figure out this mapping. So x negative and z negative inverted, right? And this one is to go from 0 to 1. Let's see, there is a... Okay, and then you have the 4. I have that here as well, right? So once you have this value, and we figure out that it needs to do this to end up here, why don't we get there? The thing is, let's see, to do this we need to do this minus this, this plus this, and then again this minus this. And that's also the mapping for 0 to 1. So it's minus plus minus, and that's the same as the mapping here to get there. So you need to translate where you come from, the mapping where you come from. Okay, wait. So if we do I have a breakpoint here? Let me just get a breakpoint here. So let's do quick watch. I need to get a later. Let me just get a breakpoint here. Okay. So now I have mapping, scanner, mapping 0 to 1, right? So 1, and then we have 1, 4. Okay. 1, 4 dot offset. Okay. So what if we say map that value, but we use the 0, come on. That was messed up. Okay. Quick watch. Okay. Map this, comma 0, 1 mapper. And then we do that dot offset subtract invert this. Okay, let's see. If I do this, do I get my values? No. But, and then I need to invert that again. Okay. So I need to add that. So I can do invert this. And now I have my values. Whew. And that will give me -20. Okay. Jesus. I figured it out. At least the first part. But how in God's name do I know this? Okay, let's break it down. Let's break it down. So the value is the old offset and the old mapper. Because I need to take the new value with the old mapper. Okay, let me just see if I can figure this out. Because I have that pathfinding code. Okay, so here, this works. Boom. My wife is asking when I'll be home since it's getting late. I'll try to see if I can figure out this and then I'll call it a day, I think. Let's see. So basically, where we come from, yes. Because this one is where we're going to, it's where we come from, versus that one. So this is where we came from, what we are now, where we're going. So this will be the from and to that are currently there. So let me just try to see if I can. So this will be from, to, and then option dot key. this will be from to. So this would be value equals this. Actually, we pass this as the value. It looks bananas, but let's see if what this does. The given key 4 was not present in the dictionary. Okay. Why was the from not updated here? Let's see. From is 0, 2 is 4. Yes, we don't have that. Okay. Okay. So this becomes actually can I even do this? Dun, 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 dun. In this case, option is 1, right? So would this be... Let's see. This would be value. This feels wrong, but this feels wrong. Feels wrong, doesn't look wrong. Let me see. Let me think, let me think. Okay, so given those numbers, how did we do? Because I recognize some of them. So this one, these outside ones still need to be flipped by that rule. The second one is totally off. But let's see. Yeah, the third one is okay. The second one is bonkers. So let's see if I do this. The map seems to be an issue here. I wonder if I just do this. I'm sure it's totally wrong, but yeah, that's not correct. Okay, so messing with that is not the way to go. So what if I don't map it at all? What happens then? Okay, that doesn't go. That's wrong as well. Okay. Okay, so I really have to do the mapping. The thing is, I need to get the mapping from the place before. So I wonder... I really wonder... I actually have scanner mapping here, so... but I need the one before this, so... Oh, do I need to... Wait. Wait a second. This might be crazy enough to work. Nope. So, like what I discovered before is that I probably need to do the mapping of the one before that. So I'm just wondering if I do this, if I can code it manually to the right answer so that I know that I'm chasing the right path. Okay, so in this case, path that we need to take is like 4 needs to go to 1, needs to go to 0. Okay, that's interesting. 3 can go to 0. Huh? Wait. Ah, okay, I'm misreading here. Okay. Yeah, 1 can go to 0. 3 can go to 1. Okay. So 3 can go to 1, can go to 0. It says here that 4 can go to 0 in one shot. Okay. What happened here? No. And 2 can go to 4. So 2 can go to 4. Can go to 1. Can go to 0. Or actually, from 4 to 0, right? Because apparently there's the path. And we already had 1 to 0. I'm really surprised that there is a 4 to 0 path. Key 1 and 2. Man, this is so... I need to look at all the keys in here. Okay, let's see. Let's start over. 1 can go to 0, 3 and 4. 0 can go to 1. 3 can go to 1. 4 can go to 2 and 1. And 2 can go to 4. Okay. So basically everything can go to 1 and then to 0, only 2 needs to go to 4 and then to 1 to 0. So we had this hard-coded thing here. So what if we... So this was from 4 to 1, right? Let's close this. So from 4 to 1, we get this, and that is correct. So what if we add a step? Before this. Okay, that was that. So this was, let's see, 4 to 1. So let's do 2 to 4. So this would be 1, 4. Come on. 1, 4. And this would be 4, 2. Okay. And then we need to do that same thing. So now if we feed this into the other one, let's see, because this should then give us the 2 to 0 mapping. Which it doesn't, right? 2 should be 11, 05, 12, followed by 30. Okay. Nope. Let's see. Do we need to invert this one? I wonder if I need to actually translate this from the the 4 to 1, so 1, 4 here. No, we did that already. Yeah, that makes no sense. So we had so the 410 trick, that was this. So this gives us from 4 to 1 to 0 the translated correct path. So that uses the offset from 0, from 1 actually, the offset from 1 to 0, and it removes the inverse of the mapped offset from 1, 4. So I wonder why that wouldn't work for this one. Because we know that position already. So let's say we have 4 here, and we, instead of that, we just remove this literal. Oh wait. What do we get if we do this? I wonder if we need to do a mapping and then do another mapping. Oh man. The thing that I don't get is this one. Okay, we made this one work, but we didn't do intermediate steps there. because let's see. This one is let's see, position 1, right? Ah, that's actually not correct. It needs to be the inverse. Invert. Oh yeah, that is going away from 0 to 1, so okay. So 1 to 0. Is that the same? No, okay. Going from 1 to 0, we get actually the position of 1. So basically the position of scanner 1 is in scanner mapping 1 to 0. Yeah, because you add this to 0, 0 and then you get there. So that is correct. So if you wanted to go from 1 to 0, you need to subtract this from the value and you get to 0, 0, 0. So that is correct. Right? Okay. Okay. Like the same way, if you subtract that from 0, then you get the other way. So that is also correct. If you do 0, 0, 0, right? Okay. So that is basically correct. This offset here is correct. So what I don't know if there is no which 4 to 1. So what did I do just now? This one, right? So if I remove that one, so what happens if I remove this from okay, so that one isn't correct. I need to I actually hit Streamlabs. Let me kill that one. Boom. So let me see. So here we have 0, 1, this 1, 4. The answer should be this. And that brings me back to the mapping, like how can you unite these? Because in this case, I think I might need to look at the mappings, like for each of them. So you have for 0, 1, you have minus x, y minus z. For 1 to 4, you have x minus y minus z. And I know they are switched there, but just bear with me for a second. So this one should flip, this one should flip, and these shouldn't flip. So when I look at how that works, so like I think it's due to like with the operators that I have to do times -1 for x times -1 for I times 1 for z. Or not. Because you need to add so you subtract. In this case, this one needs to be negative. So I'm just thinking about the mapping here. Like this is a negative mapping, this is a negative mapping, this one is a straight mapping. In this case, these need to be like flipped, which doesn't correspond that way here, I think. Well, Anne, let's see, it says x minus 1 and z minus 1. Yeah, I can't figure it out right now. I think I need to call it quits here. I'm so close, but in this case, this should be read as like, but we do the inverse there as well. So we take like the inverse, so that would be 68, minus 1, 2, 4, 6, minus 43. I think then it adds up. Yeah. Right, so you take the inverse of the target there, and that's what you see here as well. You take the inverse of the offset here. Not sure that really needs the mapping, but So this whole line, maybe it just worked because the mapping negated that as well. Trying one more thing and then I'm shutting it down for today because yeah. I think I already tried this as well. Oh no, that also messes with things. Nope. Okay, I need to call it quits here. It's very late. And I need to keep my sanity. Not that this will let me sleep, because stuff like this will keep me awake, but yeah. I think I need to call it quits here. And probably I think I could do part 1, because I'm able to identify all the beacons and which one is which. But yeah, I need to draw a line somewhere. I feel like I'm really close, because the outputs, it's just a way of figuring out the last part, how to walk back. Maybe my assumption here is wrong, and my my offsets here are wrong as well. But yeah, it looks to be very close to a solution. So yeah, I'll need to give it a rest and maybe try again tomorrow, finish it. So yeah, I want to thank everybody that stopped by and see me struggle, and maybe see you guys tomorrow. Bye bye.